Ron Daniel is director of Elsevier Labs. He'll be talking about some of the work that Elsevier has been doing to support some of this work. Ron, we can see your slides. You should be set to go.
Thank you, Todd. And how's the audio here?
Sounds good.
Okay, great. So thanks everyone for taking the time and paying your attention here. For those of you who've worked at large organizations and are used to the obligatory safety slide, I'm not going to be able to show you the way to your exits, but I can remind people, to practice your social distancing, just like my dogs are doing this morning. So one thing when it comes to upskilling your data science team is, what kind of people do you need to be looking for? This picture, the Venn diagram that, was shown earlier, comes from 2013. And somehow this got turned into, not what data science skills were needed, but what kind of person you had to hire, that you had to hire somebody who had all of these skills. And, then once that idea got out, it's developed in three different ways. One of which is, you can't hire these people. They're like unicorns. They're just not really out there. Other people took this diagram even further and added more important skills on here, a whole new large circle around soft skills for consulting or, understanding the problem that users are dealing with. But really the thing to keep in mind here is that, this isn't about an individual who needs to combine all skills. We need to be looking at a data science team, not a single individual or some kind of mythical unicorn. So you'll see out there, a number of places where they say data science is a team sport. This one, happens to be some quotes from Oracle, but, you'll see things from a number of places if you look for that. We need to be looking at individuals with different skills and assign them different responsibilities to do what it is our organization needs to be doing. My only quibble here is where they say, there is the data science process. And I think that, that's going to vary depending on a lot of different factors. So if we have the question of how do I build data science and data engineering skills into my organization, I think a lot of you may know the joke about asking a consultant a question and getting the consultant's answer, which is always, it depends. Well, what does that depend on? Primarily, this is going to depend on the customers that you're trying to serve and their needs. And, this is something that Courtney mentioned earlier around patrons and their needs that vary by task. What is it that your patrons or your contributors or whoever, what are they trying to do? Who are they? What are their needs? Other things that are important here: what kind of organization are you in? How big is it? How distributed or centralized is the culture? What kind of tasks does your team need to take on? What are their current skills? Where are you getting data and in what formats? What kind of budgets can you expect? What kind of tools do you use now or do they use now? So on and so forth. So let's talk about that a little bit. When it comes time to developing products within Elsevier, we have 8 steps that we like to go through. And part of this is market definition, or who is it we're trying to help? And then, what is it they need to do, and so on and so forth. And what I've tried to do on the right-hand side here is characterize these by the intensity of the data science and data engineering work that goes on here. And it's not all confined to one place. There is a lot of work around data science in this area that we call generating insights. understanding what is it that's in this data, and what do the subject matter experts say is important, and what can we get at with AI and machine learning and natural language processing type tools. But it applies really throughout the entire process. What is it that customers are trying, or in our case, customers, or in your case, perhaps patrons are trying to do? We need to know a little bit about that. And, there may be data science activities that go on there in terms of, crunching data that come in from sampled usage logs or things like that. Or at the end in creating user interfaces, and in particular in doing visualizations of the data. Those are data science and engineering activities, but quite a bit of work in data engineering with understanding what the data needs to be and how it should be organized and how we acquire it, and what we do in terms of mapping that to entities and storing that into structures for serving up. Okay. Another thing that matters is your organizational structure. How diverse versus centralized in it is it? So a lot of companies are organized with an engineering and a marketing and a finance department and sales, and so on and so forth. And they may have a data science group down, one or another of these major divisions. But that's not the only way things can be done. Those of you who may not know about a company called Stitch Fix, which is basically a subscription fashion service, they started out, I wouldn't say with the luxury of doing this from scratch, but the necessity of doing it from scratch. And they decided very early on that, data science and being able to make recommendations on the kinds of fashion that people might find interesting, was really core to what the company was doing. And so they have a data science team as a top level peer. And, if you have your chief data science officer, then that's really a different skill set that is needed than, somebody down the hierarchy who, is a manager or perhaps a director level person. Another thing, this picture on the left is overly simplistic. Something you'll find is that there are a lot of data science teams in most large organizations, some in marketing, some, in finance or business operations or this or that or the other. And so we get back to the teamwork, and needing to collaborate between these teams and not try to be the, be all end all of data science within the organization. Another thing that your upskilling will depend on is the team structure. So a common arrangement is shown on the left, where there's a machine learning engineering team and a research science team and an ETL team for extraction transformation type tasks on the data. That's not the only way of doing it. Stitch Fix, again, they tend to divide things up by particular projects. And depending on the stage of the project, its size, its importance, they'll have one or more people working on these, and they'll combine some of these tasks, depending on their particular skills. They don't tend to do a lot of the bulk extraction or creation of new platforms or paying attention to what's going to happen when we roll this feature out and we're trying to make it work at an acceptable performance level around the globe. That's something where they rely on their algorithms platform. But it's not uncommon to have somebody who's wanting to test out a new feature, and they'll take some of the existing data and do a little bit more data transformation on it and test out new machine learning models and mock up some visualizations of how that might be rendered, so on and so forth. Okay. Another big area of or another area to pay attention to when you're looking at skilling. What kinds of tools are being used? Tableau is something that you may or may not have access to, or that people in your organization may or may not have access to. And other people will have to go off and use D3 or Matplotlib to do their renderings. And that will have an impact on what kind of training you need to provide, what kind of skills you need to acquire, so on and so forth. Now, they may say that these are the most commonly used data science tools. There are a lot of others out there. Python and R come pretty quickly to mind as essential glue in accomplishing these tasks. TensorFlow has competitors like PyTorch. There are sort of machine learning workbenches like SageMaker or KNIME, dedicated NLP libraries like Spacey, platforms like Databricks or, data manipulation, human understanding, human labeling platforms like Mechanical Turk. So here again, this is one of the things that really matters when you're trying to say, how do I provide skills? How do I, up the skills of my data science team? Another area, where does your data come from and what kind of data is it? So we do a lot of stuff with the scientific literature, and a certain amount with usage data and citation data and so on and so forth. But some of these have particular requirements. If you're doing work with healthcare data, then the people who are doing that need to have HIPAA training if they're working in the US. And there are particular requirements on how this data has to be stored and how it can be used and how it's anonymized and so on and so forth. Similarly, for personally identifiable information, GDPR sets particular requirements on handling that in the UK. And so you have to have special training depending on where you are and what kind of data you're working with. The types of projects that are going on will have an effect. So here are a few projects that we've been doing in the labs group recently, analyzing publications to find out, where are they acknowledging that, some agency, the National Science Foundation or, the National Health Service or whomever, funded this research. And so can we find that information? Then can we aggregate that and turn it around and say, okay, here are the studies that came out of this particular grant or from this particular grant funding agency. Can we give a report to the European Commission on, what's been published based on things like their Horizon 2020 grants? Some actual, what I would call, biomedical research, looking at the literature and trying to test a couple of hypotheses. One called the cold mouse hypothesis, that if you are keeping your mice in warmer conditions than colder, they'll undergo less stress, and that you'll get different outcomes from your tests. Well, it turns out that there's just not enough data on this in the literature to really tell much about it right now. The hypothesis is too new. People only rarely report the housing conditions in terms of the temperature that they keep their mice. So, sometimes you do the analysis and what you come up with is, well, we can't really tell. It's the way it goes. A couple of other things going on here as well, but I'm going to skip those. So it all comes down to this. How do you build data science skills in your organization? Well, I think rule number one here is don't forget the data engineering. There is a lot of data manipulation that needs to go on, and a lot of deciding on how data needs to be spread around and organized, and it's not all ETL, but there's a big chunk of it. I think the other main notion here is that one type of upskilling doesn't fit all. You're not going to find a silver bullet where you can say, here, take this training class and, it'll all be good. Skills can be obtained and upgraded in lots of ways. Formal education, maybe you're hiring people who have gone through a data science program, or you're working with, student interns who are going through such a program, or, people who have had, instead of a data science education, they've actually had a statistics or, programming or, a subject matter expert background. Metis or other kinds of boot camps can be used. One of the people in our team, has, done postdoctoral research in biomed, but not in computer science. They went through a Metis boot camp, and, this was something that had become of interest to them while doing their postdoctoral work, and getting into, getting the data manipulated and visualized and understanding what was going on there. And, a very productive member of the team. Maybe you'll hire training consultants. Our company has put in kind of a low level layer of machine learning training, what we call machine learning white belt, that's, commonly given to, pretty much all of the developers, just so they know a little bit of what's going on with machine learning. Not that they're going to necessarily be able to take that and instantly do a machine learning project, but they at least know what kinds of things can and can't be done, and will have some awareness of what the opportunities are when projects come along that may or may not be able to use that. What I think is really important, and this was also mentioned earlier, just continually self-developing through MOOCs or, the, very good materials that are available online, most of which is for free. As I mentioned earlier, sometimes some skills are going to require others. So if you don't use Tableau, but you're using Matplotlib, then, people have to have Python programming skills. You just really can't use it otherwise. If you have R as your language of choice, then ggplot would be the equivalent here. So, I'll sort of wind this up by saying that leadership has to show the direction. Who is it that we're trying to help and how? But, it's a bit much to expect the leadership to take all of these different factors and weigh them and come to an individual data science team member and say, oh, here, you should take this kind of training. Usually the team members, they know what their skills are and what the rest of the team can do. And they will frequently know best what it is that they're going to need to do to improve their skills and, carry forward the tasks that are given to the group. And, Courtney had mentioned that, there's lots of ways for people to learn things. I think that's very true. And, Julie had gone through a list of data services details. That slide, I think, was excellent for talking about different purposes, different tasks that your data science team might go on, might undertake. So with that, I'll stop here and thank everybody. If you have any comments or questions, my email is here, and be happy to hear from you.
Great. Thank you so much, Ron.